mechanical engineering or electrical engineering, automobile engineering, biology, biotechnology. We have all these domain specific programs, majors. And then when electronics and all took the mainstream, we have seen the emergence of these cross domain programs like mechatronics emerge. Of course, they did not take up much, but our program, I was into a biomedical engineering program, which was a cross-functional, cross-domain program. We had anatomy and physiology, biology, biochemistry, biological control systems. We learned computers in medicine, electronics. So it was a cross-functional, multidisciplinary program. And now, sir, this is to you. Maybe we should work on something called mechanical intelligence as a major. Because artificial intelligence, to my understanding, is all about creating the domain level artificial brains. We are biomimicking, we are creating those small brains with those knowledge packets and linking those knowledge packets to the neural engines. And right now that is happening at a level 0, level 1, and maybe level 1.5. I mean, on a scale of 1 to 5 or 1 to 10. So the crossed, without domain, there is no meaning of artificial intelligence.
Totally.
Right. So the other day, Usha and myself, we were looking at one of the article where it was more about gene libraries, and because that's more on the biotechnology coupled with AI, there's a huge opportunity there, an untouched opportunity, and create those kind of millions of libraries are really required specific to these organizations, because these are the fundamental building blocks for the dry labs. So if they're doing any kind of a drug design or some kind of a, the vaccine or some kind of a, the medicine. So till now the process is more like, we go to a lab, we try to test it on a animal or a rat and a mice, and then we move to the human trials. It's a lengthy process, but these gene expressions and the gene data being collected in volumes, that again, the simulation applies the AI, from those GANs and other models on these gene data, and in the dry lab itself, hardly in few months, we can get a result of how this chemical compound can actually, react with this kind of a gene. Because when it comes to the clinical trials and all, I was part of clinical trials for 9 months when I was doing my master's. I know how it works. So we need to, collect the, their geographical data, their racial data if they're a Hispanic or from Asian origin. And when it comes to the drug delivery part in the clinical trials, all this gene and the DNA part is taken into, they collect the plasma and we ship it to, the primary investigation centers and all. All this process, this is only specific to one domain. Maybe GE was doing more at the mechanical side or more at the automobile domain. So every domain is being touched with this AI. And AI, if somebody is looking at it as just a technology, no, that is gone. So AI has value only when it is connected to 1 or 2 or 3 or multiple domains. Right now it's more at the very initial stages where it is connected to one domain. So maybe programs like mechanical intelligence, biological or botanical intelligence, kind of a cross-disciplinary programs can emerge, where we combine the strengths, and these guys actually, the part of the program, they can work on something like that, and we'll be very happy to collaborate on that front, sir.